functions and the first derivative test. So the first thing we're going to do is define what increasing, decreasing, and constant mean. We say a function is increasing on an open interval if the first derivative is positive for every x value in the interval. So we're going to define it from a calculus standpoint. In algebra, we just looked at the graph and we estimated where it was increasing, where it was decreasing, and where it was constant. But with calculus, we can actually use the derivative and whether the derivative is positive or negative or zero to determine whether it's increasing or decreasing or constant. Decreasing is defined as a function on an open interval where the derivative is negative for every x value in that interval. The rate of change is negative. So that just means that as the x's increase, the y's are decreasing. And then it's considered constant if on an open interval the derivative is 0 for every x value in the interval. So we'll pause there and see if you have any questions. To locate intervals where a function is increasing, decreasing, and constant as well, what we do is we find the critical numbers, because if it's going to switch from increasing, decreasing, or constant to another, it's going to happen at a critical number. So we'll find the critical numbers and we will set up a first derivative sign line. What that means is we'll be plugging into the derivative and we'll be testing numbers to see whether they're positive, the derivative is positive or negative there. And here's a quick note. A function is said to be always increasing or always decreasing if it is monotonic. So if you ever hear the word monotonic, that just means that it never changes. It's either always positive or always negative or always constant. The best example of a monotonic function are the basic cubic functions. That one is always increasing, this one is always decreasing, and then of course lines. They're either always increasing, always decreasing, or always constant. For our first example, we want to find the open intervals on which a function is increasing or decreasing. So the given function is f of x equals x cubed minus 3/2 x squared. If we're going to find increasing, decreasing, we first need to locate our critical numbers. So we'll take the first derivative, and we get 3x squared minus 3x. So the nice thing is it doesn't have any denominators. It only has numerators, so we'll just set it equal to 0. We can factor out a 3 and an x, and an x minus 1. And we get the critical numbers of 0 and positive 1. So what we're going to do with those critical numbers is we're going to make a first derivative sign line. So make sure you have located your first derivative. We're going to draw a line, just make a little number line, and the only numbers we're going to list on it are going to be our critical numbers. So we're going to put 0, and we're going to put positive 1. And then we need to pick numbers in each of those 3 intervals to test. So we are going to test a number from here.
-1.
So we'll type -1, and one from here to here.
1/2.
All right. And then anything over here. 2. And we need to take those 3 numbers and we need to substitute them not into the original, but into the derivative. And we want to know if that derivative is positive or negative. You don't actually even care about the numerical value. You only care if the derivative is positive or negative. So let's take -1 and substitute it into our derivative. And we could do that here, or we could do it after we factor it. It really doesn't matter. So if I substitute -1 in, what do I get?
6.
Positive 6. So this one equals positive 6. So we say that the derivative is positive here. We'll label this. Then 1/2, if I substitute 1/2 in,
Negative
I get a negative what?
1/4.
Like -1, is it 1/4?
No, 3/4, sorry.
Negative 3/4? Doesn't really matter. We just know that it's negative, right?
Yeah.
Alright, so we say this piece is negative. And then at positive 2, if I substitute in positive 2, what do I get? Positive 6 again, right? Okay. So it looks like our derivative is positive from negative infinity to 0, negative from 0 to 1, and positive again from 1 to infinity. So let's translate that into terms of increasing and decreasing. And we don't have any areas where it's constant. It is increasing in two different intervals. This one, negative infinity to 0, and again from 1 to positive infinity. It is decreasing between 0 and 1. Make sense? So if I had to guess, from what I know about cubic functions and from what we've determined here, this graph is going to look like this. Make sense? And from negative infinity to whatever this point is, 0 comma something, and we don't know, we didn't find it. And then this point would be what? 1 comma something. So increasing, decreasing, increasing. Make sense? So this kind of gives you an idea of how you could graph something very quickly without a graphing tool.